today's webinar where we're going to be diving into UNS and how it helps to create a foundation for modern operations. My name is Ellie Allen Baith, and I'm a content marketing manager here at Flexware. Before we get started, just a couple quick housekeeping notes. First, if you have any questions, feel free to drop those in the questions tab of your toolbar at the top, and we will answer those once we finish up the presentation portion today. Secondly, we are recording, so we'll make sure that you have access to that recording shortly after we wrap up today. Now that that's out of the way, I'd like to introduce the two speakers who are joining me here today. So I'm here with Jacob Clodfelter and Brent Maringer. Jacob is a solutions architect at Flexware Innovation. He is passionate about helping manufacturers embrace emerging industrial technologies and adopt modern data-driven practices. And Brent is a business development manager. He's been with Flexware for close to 5 years, and he works closely with industrial manufacturers using his deep expertise to help modernize and transform operations. Jacob, I'll go ahead and hand it over to you to get us started.
Awesome. Alrighty. It should be this one. Let me know when you can see the screen, Ellie.
Yep, we can see that.
Okay, so what we're gonna do here, I think this meeting we really wanted to talk about different perspective on UNS. There's so much material out there, and when we produce this content, I really try super hard to provide as much value in the narrative. So this one's going to be a little bit different. And this one, I think our message we want to make more simplified. So I want to paint you a picture here. We're going to go through a series of demonstrations starting with a very simple demonstration, then a little bit more complicated one. In the very end, I'm going to show you the super far future of current thought in this space. So all right, so this one's going to be pretty easy. So we've got a room of 6 different people all speaking a different language, and we have a task. We need to have them all be able to talk to each other. And this is an analogy for what we're doing as system integrators. So let's try to solve this in the most simple way possible here. So when I draw these arrows, this is the Dutch person, the Dutch speaker, learning Italian. And now he's learned Spanish. Now he's learned French. And now he's learned German. Okay, so this is 1, 2, 3, 4, 5 different languages that the Dutch person has had to learn. And we still haven't solved the whole room being able to talk to each other, right? So the Italian person needs to learn Spanish. The Italian person needs to learn French, so on and so forth here. And we can sum the total number of different times that a speaker has to learn another language here. And I know the math of this. It ends up being 25 different languages that all of these different speakers have to learn. 25 total languages learned in this environment. Okay, so we solved it one way. That would mean all of them can speak to each other. But let's see if we can solve it an easier way. So I'm going to pick the language that this is true of globally. It doesn't have to be this, but I'm going to pick English here. So what happens if everybody just learns one language? Let's see what the math is here. Okay. So we've got this here. All of these speakers are just learning one language. They have to maintain competency of just one language. And now I have 6 connections. So 25 to 6 connections is a huge order of magnitude. And remember, I only have 6 speakers here, which there are a lot more languages in the world. And now everyone can talk because they learned this common language. Okay, so that's, to me, I think that's fairly obvious what the advantage is here. So now I'm going to take you to what that looks like in manufacturing. And hopefully, as I show you this demonstration, just think back to that language example and realize that they're not different at all. Okay, so you guys can see this video, right?
Yes, we can see it. Yeah.
Okay, all right, so so remember, it's just the 6 again here, but in our space, instead of English speakers, we have machines, and our task is to get those machines or systems to talk to one another, to be able to talk to one another. Okay, so this is like the languages here being populated, and these are typical systems that we have in a manufacturing environment. So we're going to do the same exact thing that we did for the languages in this example. So we're going to have the PLC talk to the data warehouse, ERP, SCADA, MES, CMMS. So that's 5 connections. And the math is going to end up being 25 total connections. That's one more, and we're going to show the whole diagram here. And what this is called point-to-point connections, and it's also being called digital thread. And this is what most people do because they bring in a contractor, there's like a one-off method, and they get one application talking to another application. That's the equation, by the way, and you can make note that it's an exponential equation. You've got a n times n term there. Okay, so now we're going to show UNS. Remember back to that language example. There's nothing new happening here. It's the same, it's a different problem space, sure, but the mathematics and architecture of that language example are identical. What's kind of funny too is that machine-to-machine communication has a lot of parallels with language as well. We won't get super in depth in that, but just trying to illustrate that the examples are actually much more related than you may think. That's UNS, and that's just N. So N is the total number of applications. So the number of connections in a unified namespace is always just the number of applications. So that's a linear equation versus an exponential equation. Okay, so what I'm going to do here is I'm going to plot the difference in total number of connections as application number rises. So what you notice here is that as the number of applications in an ecosystem increases, the total number of connections between a unified namespace architecture and a digital thread architecture diverge rapidly. That's because the digital thread architecture is an exponential equation. So it gets worse, much worse, as the number of applications increases. And a lot of people will say, you look at that 5 application count, and it's hard to see the scale there, but it's 25 versus 6. So that's already 13 more number of connections, even at 5 applications. And some companies will say, we only have 5 applications. You have to remember that the applications aren't just in the OT domain. So these applications include things like accounting systems, ERP. It could be firewall or networking, infrastructure, inventory management, cybersecurity software. Excel counts as one. Smart Sheets, Jira, any of your project material. So when we look at unified namespace, I mean, it truly is unified. So I think in general, we're seeing upwards of 15 different applications usually, in which the returns on a unified architecture at the 15 application count, I mean, is astronomical. And one more thing to make note of here is that we're going to do this in the the next chart here is I'm actually going to put a dollar figure on each of these connections. And I'm going to put a really conservative dollar figure, extremely conservative dollar figure, because I know what it's going to show, even if it's conservative. So let's pick a super conservative value. Let's say $10,000 per integration. That means that we're only spending $10,000 to get like ERP to talk to MES. Everyone here who's in a manufacturer who's paid a system integrator to do an ERP to MES connection knows it's way more than $10,000. So in this $10,000, you have to maintain that connection too. You have to secure that connection. You have to document that connection. And that connection may be tech debt, so you may have to replace that connection. So the costs aren't just the initial cost. So this is an incredibly conservative figure. And even when it's conservative, you're going to see the cost benefit here. Okay, so this graph is the same graph here, except I'm multiplying that diverging number of connections by that $10,000 amount. So when you look at 15 applications, which I would say is pretty average, and even at 7, right? Only 7 applications. That's 14 additional connections at 7 applications. And if each of those connections is only $10,000, that's $140,000 saved. And the economy of scale increases exponentially. So when you look at larger corporations where you're pushing 25, 30 different applications, which is pretty common, you're talking just an architectural benefit to eliminate connections, you're in the millions of dollars saved. So hopefully when you think back to that language analogy, if that was intuitive, why it was simpler for everybody to talk English, which I would think, when I do that demonstration or even for myself, it feels very intuitive. The math and the architecture is identical there. So all of the intuition applies here, and I'm just giving you a demonstration of value here. Okay, so we're gonna go back and look at this. So hopefully that describes kind of latent value here. And what Brent is going to talk about, and is kind of the elephant in the room, is that, we all talk about unified namespace architecture, and I think the conversation is largely online between technologists because it is fairly abstract, the space this is playing in. And what's not talked about enough is the actual value of UNS. So we all debate the architecture. We debate, whether you should put a knowledge graph behind it, or we debate, what technologies should be used to implement a unified namespace. We debate if the unified namespace should be run on MQTT, or we debate the model. What's not talked about is the debate about how much value it produces. Like, what is the deliverable to manufacturers? What is the ROI? And one of the fundamental things that it's not talked about in UNS, and what Brent will go into, is that when you're scaling a UNS, there's one thing that you need to scale a UNS is it's the money to scale the UNS. So if you install a UNS and you're not recouping ROI immediately, you don't have a financial engine to reinvest in scaling a unified namespace. So we're going to talk about, Brent will talk about sort of approaches to solve that, but that is key. When you're talking about scaling unified namespace, you have to create a financial mechanism, a financial engine to scale UNS. So value becomes, the topic of conversation, which I think hardly anyone in our space really pays much attention to. but it's something we're laser focused on. Okay, so we do all this work, and the value is implicit to the elimination of connections, which is hard. It's hard to actually put a dollar figure on that, or that elimination of connections is a cost that you don't see until it hurts you. So a lot of companies will, you look back at your track record of all of the money you spent, all of your integrators to connect to your business. That's kind of like an absorbed cost, right? Like you don't look back at all of that cost and try to analyze how, why you had to spend that much cost. And if you project a future like I just did, where your system integration cost is much lower, it's hard to like prove what that gain would be if you had gone digital thread, right? Because you don't have the actual differential to prove that value, but the value is there. It's a default. So this is what companies actually do look at, right? So what I'm showing you here is our prove it demo, where it's full on. I mean, we connected to, I think it was at the end of the conference, over 500,000 different topics. We employed a knowledge graph behind the UNS broker. And this knowledge graph had over 6 million. These are 6 million nodes that I'm showing here. That allows us to do just like incredible things. Um, we've been doing workshops with customers recently where they have deployed Unified Namespace and they're in a stage of their journey to actually begin utilizing AI. And the ability of the tooling is just staggering. I mean, I can't even put into perspective. Um, what may help is, this is ad hoc time series prediction on any value point on any tag in your entire unified namespace. And this invocation was a single day. So we're in a world where once you have unified namespace, you could have a dashboard like this and value within a week, which is just staggering. This is so this gets a little more technical. This is multilinear regression, which is statistical ML models being applied to unified namespace. So if any of you out there are technologists, you'll appreciate this, but this is full statistical ML on demand. So think classification models, multilinear regression, time series prediction, trivial, just absolutely trivial. I know that there may be some SESME enjoyers on the call here. So, and I myself am a SESME enjoyer. So this idea that we need to apply standard models. I think modeling is largely a conversation for another day. But once we have a unified namespace, this challenge, I always try to paint this picture for people. One of the first things you'll run into when you deploy a unified namespace is this uh, constant conversation on what the model should be, like ISA 95, enterprise area sightline cell. That is a secondary consideration, by the way, to this argument. And I can absolutely claim this, the modeling exercise is easier than it's ever been. Modeling is not nearly as important as people make it out to be. And what I'm showing here, this is an AI agent doing autonomous modeling. So it's taking this machine, this is a real machine that we have running real PLC code on the unified namespace, and it's creating the SESME model. An AI agent is creating the SESME model. So that's why modeling has become largely a trivial exercise, is because agents can model themselves. So this human exercise of looking at data coming across the UNS and saying, oh gosh, I need to deliberate on what the model should be, can be an agentic process, is what we're showing here. All of these topics that have been generated across the Unified Namespace are all derived by an agent. So agents have decided which topics to publish data on and where to publish them to, what the governance model should be. So we're in this world. It's just so exciting. It is so exciting. I can't even put into words. Everyone, you'll see it on LinkedIn. Everyone who works in this space as an engineer is basically saying, I mean, it's a new frontier. It's like I like to say it's like the gold rush. It does feel like the gold rush. Yeah, and what's even better is it feels like the gold rush and you're already there. You've got the equipment set up and you're hitting gold. That's what it feels like. Um, Now, all of this is stood on the back of this. So I want to show something super simple. We'll go back to this. So, okay. So this is a concept I think is just so elementary. Okay, so we have AI, right? We want to do AI. We know AI is just enormously powerful. It is. It's the most powerful thing I've ever used in my entire career. And we want to use it, right? So we have AI and we have output, right? Okay. So AI is going to do something. It's going to give us value. So there's something missing here. We don't have output. So we can have AI. We can buy AI. We can have a whole data center. We can lease 100 H100s, and it's not going to do anything. Nothing. Nothing at all. For millions of dollars in investment. And the reason why is because you don't have an input. You need an input to produce an output. So you can buy AI. This happens all the time. People will contract Palantir. They'll contract Accenture. They'll contract um, the largest AI companies in the entire world. They'll contract Anthropic or OpenAI. And OpenAI, they'll be like, we've got, we could deploy any model whatsoever. And guess what happens? We only have one PLC connected. So what do you think happens? The POC fails. So you got to build on fundamentals. You don't do AI. You can't do AI. You literally cannot do AI until you have the input, right? That's why that's why you're building this. That's the whole reason. And if we go back here, right? Okay, so the question, so it's kind of like a pretty linear thought process here. So we want AI, we want input. Okay, what is the best way to get input? That's the next question, right? Like, what would be the best architecture possible to provide this massive input surface? Okay, so we go back to this. We say, these are the applications in our ecosystem. What is the smartest thing we could possibly do? So this is the first thing, right? This is what a lot of people will do. You'll bring in a contractor and they'll say, okay, we're going to bus PLC to data warehouse. We're done. Oh, and then you bring in another contractor, PLC to ERP. We're done. Well, we need a PLC to SCADA. We're done. Well, maybe we're not done. PLC to yes. Oh, shoot. We didn't do PLC to CMMS into our quality layer. Shoot. The PLC information doesn't have a relationship to ERP in data warehouse. We need to add that. Shoot, our whole SCADA surface, we don't have it in our data warehouse. We got to add that, right? That's what people do. And when you look at it from like this high level as a system integrator, where you've been doing projects, like you've been deploying all of this for years, right? These one-off point-to-points. You take this macro view and you say, oh my God, like what were we doing? Why are we doing this? 6, that's it. You connect to the broker, you connect to the warehouse, and all connect to the UNS. And then this input is the best. It's actually So as a technologist and engineer, this has been like one of my only focuses is what is the best way to get data, period. Like, and I've explored all, not all, of course. I've explored many different methods of doing this. And I'm serious when I tell you, just as an engineer, this is the best I know of. It's the best thing that I know of. And it truly is amazing because you go from this, exponential equation to this linear one. So it's proven in the math. The math is just self-evident. So now we've got the best of the best input. And now that we have the best of best input, we can do whatever the heck we want. This is real live PLC. This is fully autonomous MES. So this is autonomous MES, by the way, was what I'm going to show you. An agent invoked this MES surface, right? I'm going to show you this. This one's. I may have actually done a purge on the database. I think I did. Sorry, yeah, these OE values are not going to be accurate. But an agent invoked this entire dashboard. It's extremely possible to do that. And of course, we get like chatbots as well. We can interrogate the data, etc. Anomaly detection, summarize, all kind of stuff like that. We get full leverage here, but you can't do this. It comes back to this. This is just the simplest thing ever, right? Is we because this is what people will do. They'll see AI as powerful. We need AI now. They buy AI, and they never had this. They never had this. It's such a shame. Because everyone in the space, and then the POC fails, right? And they say, 85% of AI fails because people start here. Because I guess they don't understand that there needs to be an input to it. This needs an input. In fact, so think about this. So the input to an LLM, OpenAI doesn't do anything until you give it a prompt. It'll just sit there. It can't do anything. So even an LLM needs an input. There's no AI model that exists that doesn't require an input of some kind to produce an output. Now Brent is I'm coming up to the 30-minute mark, and I want to hand up to Brent. So what you can make a mistake here is that you invest all of this, you invest all of your money into UNS, which is fine if you have that kind of runway. That's a sensible way of doing it if you have the money to spare. Most manufacturers don't have that kind of money. So what a more sensible way is build this entire stack on UNS, but you do it for one use case. So you just do PLC, let's say, and you go all the way end to end to AI with your PLC data for one use case and get your money back. Do a use case that gives you money today. And you can do this in like a month. And so long as you have the vision that the next use case you solve is building out the UNS, now you've got this financial mechanism to keep pumping this, and that's scaling UNS. That's scaling UNS here. So that's a way to tackle it. You can either do it all at once and pay a lump sum, which is a large investment, and you architect it, to the nine, which I've done before. And of course that does work, but most companies don't have that kind of runway. So there is a easier and simpler method to get started. So yeah, I hope that was a different look. It's laser focused on ROI, because we can debate architecture for hours. And really at this point, the architecture is largely solved. From a technologist standpoint, you look at UNS, you're like, what is UNS? There are hundreds of really nerdy technologists solving it to the nth degree. So if you talk to any of us, it's gonna be awesome. It's going to be great. There are SIs all over the market that have nerdy people talking about this. Just leave that to them, you know? But if they're not talking about this, now you need to be concerned. If they're not telling you how it pays for itself, you know, maybe that is what you need to be concerned with, is make sure that your SIs are understand this. So, okay. So yeah, that's all I got. I think I can hand it off to Brent. We're gonna leave 15 minutes, like a really large block at the end to have questions, because I hate just lecturing and then, you know, there's no engagement. So hopefully you guys have questions. We're gonna answer them.
All right, thank you, Jacob. Let me share my screen here. All right, does everybody see my screen here? Or Jacob, do you see it at least?
I do.
Okay. As Mr. Claude Felter mentioned, I am going to talk more about the business side of the UNS concept. And what Jacob was kind of hitting on at the end when he was mentioning the engine, I like to think of it like the word momentum, right? So as you're doing efforts with this stuff, this technology, momentum is key. And maintaining momentum is going to help you and your company in the long run. So that's what I want to talk about today, is that, and then how you do that, how you go about doing that, at least how I think or how I see it from my perspective in this industry. So as we get into this, I think it's important to acknowledge that the UNS really is a disruptor technology. In the upper left, you kind of see, like, that's just the way that we've been doing integration projects for decades. I mean, 30 plus years, you've always done it that way with point-to-point integrations. So the UNS is challenging that, and it's challenging the status quo. So there will be pushback, and the UNS concept does have a way to go to establish itself. So what you're probably all already doing or thinking about doing is starting small with, you know, art of the possible concepts or proof of concepts and pilot lines. Those are critical and they're important for educating end users. And, you know, it's important to start small, prove the validity of what you're trying to do. And then as you succeed there, you start to build momentum. But it's very important not to confuse pilot and POC success as the end. That is only the beginning. And as you move through your POC or pilot, be thinking of the next use case that you want to leverage for your UNS project, because that will help you take the next step and to build momentum. So the use case is kind of what I want to focus on today and talk about the use case and ROI and how they're related to each other. So this slide is a lot to take in, but then again, there's a lot to consider when you are defining a use case for your project. And this is, we're talking UNS today, but this can really be any sort of technical solution. And I'm not going to read all this to you, so feel free to take a screenshot and digest this later. But the main thing, the main parts of a use case are at the top here. So, and all this is probably stuff you guys already know and have been doing in your careers, but you always start with the problem. You know, what is our pain point and why do we have a pain point? And, you know, and then explain more about what your problem statement is. All right, so then the next thing for a good use case is the theoretical solution. So this is what you think you can do to solve the said pain point. So in our case, it's likely going to be technical-based solutions like a UNS, AI, things of that nature. But this is what you think you can do to solve the problem. And then you go on to your value hypothesis. This is what the value you think you can realize by leveraging the technical solution you think will work for the problem that you most certainly do have. And then as you get to the right, this is, I have it listed here as data and infrastructure requirements, but really it's whatever you need to fulfill your theoretical solution to realize the value. So all these things go together and build off each other. But what you're doing here is you're kind of making a case that you can present to your leadership to say, this is what we need to do and why we need to do it. This is how we're going to fix it. This is what we're going to get in the end. And this is what I need to make all this happen. So the rest of everything below here is more information for you to gather and prepare so that use case is well defined, so that you are well prepared to present this to your leadership and to get buy-in and support. So a couple of important ones though to hit on is like number 2 here. So what insight is being produced in this use case? And an insight is really, that's where data becomes information. This is, oh, hang on a second. Yeah, so this is like things that you don't know. Like, what do we not know that we can know now that we have a UNS, right? Those are things to be thinking there. Number 3 here is another one. And, what decision will this insights affect? The decision is really where information meets human thought and human processes. So this is kind of where it all really happens and the main thing that is being driven by the use case. So it's important to spend some time on that one. And I didn't, really, number 4 kind of leans into that, is like, who will be making this decision and what are the possible outcomes of this decision? Those are all things to think about as you build your use case. Number 7 here is also important, is the KPI. As we all know what KPIs are and how important they are to business, and most importantly, our solutions that we provide, this is what's being monitored. This is how we know if whatever we're doing is winning or losing. And then finally, number 8, this is where, what is the KPI value relationship? Now, obviously, value and realizing value and increasing value is really the goal, right? That's what we're all doing this for. That's why businesses are in business, is to realize value, run the company, maintain employees, and all that. So that's very important that you establish what the value will be of this use case and what happens with the value when the KPI moves in a positive, or negative direction, right? So if we do these solutions and we can increase this KPI by, say, X%, then our value should increase by X%, and therefore comes our ROI. So, like, a little parting statement here on the use case is, when you're thinking of building these and starting to build these, don't start with the platform. Don't be thinking UNS first. Start with the problem. Of course, we got to kind of skew it to UNS because that's the tool we have to solve some of these problems, and that's what we're looking for continued investment in to keep solving problems. But focus on the problem. And from what I've seen, what Jacob has shown me and his team, is that the UNS is a great enabler. It feeds into everything that we need to be doing these days with information, but without purpose, it's just a fancy investment. So as you're establishing and aligning your use cases with the value and ROI, there are 3 categories of ROI that I like to put things into. And again, a lot of you are already familiar with these, but the hard ROI, that one is the most undisputable. That is direct savings or direct, value increase from the bottom line, right? So think like, I bought a new machine. Now I have more capacity. I can make more widgets. I can, sell more product. I make more money. So that one is pretty straightforward. Or imagine you redesign a process and it is substantially more efficient than the previous process. That can be hard ROI. Soft ROI is definitely more challenging because it's more indirect savings. So these are things like quality of life improvements, or you're saving somebody some time by automating a data moving process, or you build a dashboard that puts, you used to have 4 different programs to open to answer a question. Now you have one. That's cool. It's helpful. There are real savings there, but it's not hard ROI. So it's a little bit harder to justify. And if you're going to be going after soft ROI, it's very important to do your homework, have the math laid out. Like, think of put a slide together that says, well, I can save this much time by doing this. This person, cost this, whatever it is, and really be prepared to prove the value. But the savings are real there. So, and then finally is strategic ROI. These are maybe, this bucket isn't really tied so much to dollars, but it is directly tied to think like long-term business goals, and or think really like CEO and CIO. What are their strategic goals for this year, next year, their 5-year plan? These are solutions and efforts that align with those goals. So like a big one right now is think AI. Most companies I talk to have AI initiatives. No one exactly knows how much savings there's going to be or ROI there's going to be with AI, but we all know we got to do it. And so that's a really good one for the UNS to align with, because AI and UNS go together, like peas and carrots. So that's a good one to think about as you're building use cases. And then the real effective way of establishing ROI is to hit on all three, right? That's what we like to call a slam dunk. So it's a no-brainer when you can hit all three. Finally, kind of as you guys are building your use cases, you're doing your POCs, you're building your use cases, you're proving the ROI, you're turning these from POCs, you're operationalizing them into production. People like it, they use it, you start scaling, you create this flywheel effect. And this is the momentum we're talking about. And the faster this flywheel spins, the more savings you're going to realize. And then this is where the UNS moves from being the disruptor to becoming the status quo, as we all age with it. And that is until the next disruptor comes and unseats the UNS. But hopefully we got another couple decades before that happens. Anyways, Ellie, that was all I wanted to cover today, and let people know what I'm thinking of.
Awesome. Thanks, Brent, and thanks, Jacob. We're going to go ahead and start on our questions now. So we do have one that has already come through. And so we'll go ahead and answer that. But if you have any others, please feel free to start dropping those in, and we'll open this up into a conversation. So to start us off, guys, what UNS brokers or software are out there, and what is the cost to run them?
Such a good question. Yeah, I know you're gonna get. Yeah, put your questions in because I know the questions are gonna be good. Okay, so this one is such a hot topic of debate. So, vendors all over the ecosystem are trying to capitalize in the broker space. So there are a lot of people competing in the broker space, which is good because it drives the costs down. But the costs are all over the place. So your biggest players in that space are probably Mosquito, EMQX, HiveMQ, and CirrusLink Chariot. So those are kind of the top four. So they're all trying to differentiate in different ways. So HiveMQ's positioning is like the premium enterprise like Ferrari. So they're expensive, but I think largely they're delivering on that promise. So they are the Ferrari, and I think it's pretty well believed, at least myself, that they're actually delivering on that. They can scale. I've seen it firsthand. They can scale to millions of messages, and I've seen it. So they can hold that up. I think their AI proposition is new, right? They just pivoted, so who knows? EMQX is like their Chinese origin. There's a big concern. They were built by university PhD people, like just normal nerdy people. So I have no concern over that. It's a brilliant product. It's amazing. It kicks ass. It scales to millions of messages, and they're like the competitor to HiveMQ, but they've got this like persona issue with China. Mosquito's like the entry, so they're super cheap. Mosquito's really cheap. They do POCs great. They don't scale quite as much, but they're way cheaper. And the one that I think is most interesting is Chariot is incredibly cheap, like super cheap. but they don't do elastic scaling quite as well. So we a lot of times will bring in people with Chariot just to keep the costs low as you're proving ROI, and then as you're hyper scaling, maybe you look at something like EMQX or HiveMQ. But hopefully that answered your question.
Awesome. Thanks, Jacob. Next one here is, what are some of the challenges you've seen when attempting to implement UNS?
Yeah, the biggest one is getting too like caught up in yourself. Like the big one's modeling. So you say I full commit, and then what you do is you will have these meetings where you're like, okay, we have to define the hierarchy. And there's like a meeting where you're like, what is it? Is it enterprise area sightline cell? What are the topic paths? What are the, you spend months because one guy goes, no, that doesn't make sense. My machine, has a different topic path than this, or somebody says, no, but that doesn't scale. It's all a fallacy, by the way. All those conversations are built on an assumption that is false. The assumption is that the UNS is a static entity. Like we just define this namespace and it's static. Everyone knows that a factory floor is completely dynamic. Machines get ripped and replaced, tags change constantly. So don't worry about that so much. The modeling effort is really not as important as you think it is. Start with something that makes enough sense and just start building. Like that don't get caught there. You can waste so much time. It's not nearly as important as you think it is. Not that it's not important to define a standard, but don't let that be the reason you don't start publishing. Like just get the data. That's the most important thing. And there are ways, by the way, to support dynamic namespaces. So we do that all the time. If you assume it will be dynamic, you can build it that way. So yeah.
Just to
Those are
add a
the
little
biggest
more there, Ellie, what I've observed is the technology itself is fairly I mean, not straightforward, but people that are in this space and ops technology, they'll get it. They'll understand how it can work. It's easy to point one, like a broker, to, like, say, Ignition Gateway, for example. They'll start talking. That's straightforward. So the POCs are easy to get into. They're easy to start, and they're fun to do because you're chasing new technology and it's exciting. The challenges I've seen are once you get past that, it tends to stall there, and everybody hears it. They hear pilot purgatory, things like that, and that's usually because you're so excited about using new tech and solving new problems that you don't take the time to understand, how am I going to operationalize this? How are people going to adopt it? Right? Change management, and this is not new to UNS. This has been projects 101 from the beginning of human effort. Probably is, how are we going to manage the change? How are we going to get adoption? So you really gotta, that's where like the use case and the problem statement comes in, and you can help redefine or continuously define, this is how we intend to solve this problem. This is the tool you use. So knowing that early in your process or your journey is critical.
Yeah, I totally forgot. It's like as an engineer technologist, you never want to think about that
Yeah.
part, but it's the part that actually matters. I'll do this all the time, is where you form a digital transformation team. You're all moving at like hyper speed because you fill it, you staff it with people who are, you know, understand the space and really eager and excited. And then you go you deploy this all right, and you go into like the line side operator and you look at somebody with like excitement in your eyes and you're like, we have UNS now. Aren't you so excited? And they're like, what the heck is
Yeah.
that? Like, no, no. They're like, wait, are you good? Are things changing? Is
Yeah.
my job changing? You're like, oh
Exactly.
shoot. Like, so the earlier you bring people in to your excitement, the better. And in my
Yes.
people want to be excited, and they want to feel like they're being a part of disruption. Like it's fun. Like you're not old anymore, right? Like some people feel like they're legacy. They paint this picture like, oh, we're a legacy manufacturer. Like, oh, we're so slow. We move like a boat or whatever, right? Just give your, you know, say no, we're not, and you're part of that now. Like let's not be that way. And it's not just this digital transformation team. Like it's the line side guy. Be like, no, like you. Um, and remember too, your end customer is not your digital transformation team. Your end customer is the line operator. You're building
You
for
know
him.
well. Yeah.
Yeah. Yeah.
Awesome. Another question here is, based on your experience, how long does it take companies to fully adopt UNS?
Yeah, so it's changing so rapidly because of AI, because we're moving from this traditional software development world to this AI software development world, and the 10x, 100x is real. So things are moving at light speed. And what I can tell you right now is if you start with this idea where you're going to pick one use case and you're going to go end to end, I am seeing like 3 weeks, 4 weeks, you're getting ROI and you're using UNS. I kid you not. Now, that's if you have alignment already and you've got the culture in place to enable rapid development. Um, you have to get those cards in a row to go that fast. Like you have to have IT on board. You have to have the communication structure and responsibilities like RACI in place for people to just make, rapid progress. But if you say, hey, here's your 32 core 128 GB Linux server, you've got sudo and Claude code, give it to the guy that knows what to do. Yeah, it's 3-4 weeks and you're doing something incredible.
To add a little more there, and to me, the key word there is fully adopt. Um, to fully adopt UNS, it's a journey really, and I don't, it's like almost a living type solution that's going to continuously grow as more things come online. You can realize more use cases. So you may be doing this for a while, but I think, if you were to say, how long does it take for UNS to get established in a company's OT landscape? You can, like to Jacob's point, POCs, those can be weeks, but for you to operationalize it and for it to become part of like a production process and it becomes, critical to the overall, operation, be thinking months. Like it may take 6 months from it to go to POC to be production hardened to now it's part of supervisors and managers everyday tool bag. And maybe not 6 months, right? It all depends. Everything depends in this game, but it's more than a POC.
Yeah, that's a great point. That as you're doing this momentum flywheel thing, larger and larger parts of your enterprise begin to be incorporated, but it's like you're like uh mining value. It's hard to define when you're done, like if 75% of your business is on the broker, is UNS done? No, it's like it's this you're just constantly mining, and that I think it might be, longer than 6 months to if you converted all of your enterprise connections to UNS, that might be longer than,
Certainly.
1, 2, 3 years. Um, but once you start walking, that's like the main thing is you commit, you say, okay, every we build this processing plant and every, you know, amount of gold that comes out as we're mining it goes through the same processing plant. So we've decided that, and then, then you're just going through the same.
All right, next one here is, once my data is connected through the UNS, does it become ready for AI, or are there further data pipelines to be built to the AI platforms like Databricks? And yeah.
Yeah, good question. Uh, Databricks. Okay, so the answer is yes. If you have the structure in place to enable the teams to move rapidly. So, um, connection to Databricks into a Jupyter notebook where you're doing core data science, or even like a deployed model on SageMaker or Azure AI Foundry or whatever, that could be a week worth of development with an experienced developer. The hard part in cloud usually is that you need to like do access, or your IT needs to get involved, because once you hit cloud, it's a different department. So how are we going to enable this developer to do work on both OT and IT surface? um, are the harder things. If if you had a good developer, and there are many, many, many good developers who have admin sudo access on OT and IT, and they know what they're doing, and they have Claude code, you can get a model in a week, deployed end to end, 1 week. That the challenge is enabling those people, which is hard because a lot of the what another thing, like, so AI is pushing software development into like 10x 100x. The structures that we had can't keep up, because we had this like previous assumption that, like, OT guy would do something for 2 weeks, then he would be ready for cloud to do their 2 week thing. Now it's like OT guy is 1 day. Then are you ready? Oh no, he's got twice as much. Are you ready yet? So it's almost like we talk about, our job becomes full stack, and it's because if you have AI and you understand full stack, you can go light speed. So hopefully that made sense. It's about enablement, is timing. It's not a technology challenge at all.
Awesome. This will probably be our last one, and I know there's going to be a few more questions out there, but we'll go ahead and answer those after. We'll send you an email to answer any questions we don't get to. So last one here is, if we use a powerful middleware like Ignition to model all of our tags and UDTs, does that count as a true UNS, or does a real UNS require an independent external broker infrastructure where Ignition is just one node among many?
Ah, okay, so we didn't touch on this because it complicates the issue, I suppose. But when you first start, I like to say you're phase one, which means that you're in a scaling mode of just starting scaling. So if you just have Ignition and you choose to use Chariot, the Ignition ecosystem can support all of your use case. And you could probably remain on Ignition for as long as a year. Now, when you go to phase two, which is hyperscaling, the technologies change and the considerations to hyperscale are different, for sure. But I wouldn't let that stop you, right? Because, like, I think we make this mistake of planning so far into the future about this hyperscaling scenario. You have to get ROI to get to hyperscaling, right? So start small, sure, Ignition, do a full POC on an Ignition stack, get your ROI, get your money, start building it, get momentum, create excitement across your organization, and then you use that money to scale. Then you go back and reinvest in hyperscaling, etc. So yeah, you can 100% start an Ignition, full stack on Ignition. Yeah.
Awesome. Well, thank you so much, Jacob and Brent. I really appreciate you taking the time today, and thank all of you for your good questions and for joining us today. Again, if we didn't answer your question, we'll make sure somebody follows up with you on that. But again, thanks for being with us today. If you have any other questions that you think of afterwards, please feel free to reach out to us. We're happy to answer any of those, and also to talk through how to build an effective strategy with UNS or AI or any of that good cutting edge technology that's coming up. So if you would like to do that, you can reach out to me directly at ellie.allenvaith@fluxware.com, or you can reply to that email I'll be sending you shortly with the recording link, and we'll make sure you get to the right person to talk through that with you. Again, thanks and have a great rest of your day.
Thank you.